Hello, my name is Andrew Cantu, and I'm a mechanical engineering junior student at Lamar University.
My name is D'Angelo Dunnan. I'm a mechanical engineering student. I'm a senior.
And today we'll be discussing with you viscosity for our fluid mechanics class.
Today we'll be covering what is viscosity, different fluids that have viscosity, what it's like to be working with fluids with viscosity, gelatin, a substance I found interesting when studying viscosity, and how viscosity is all around us today.
What is viscosity? Suppose you have a cup of water and a cup of syrup. When you pour the liquids from these cups, you notice a distinct difference in how each liquid flows out of it. The water pours out quickly and easily, while the syrup pours more slowly. This difference is due to a difference in their viscosities. Viscosity is actually the measure of a fluid's resistance to its flow. It can also be thought of as a measure of fluid's thickness or its resistance to objects passing through it. The greater the resistance to its flow, the higher the viscosity. So in my previous example, the syrup would have a higher viscosity as opposed than water.
Viscosity is simply explained the internal friction that it has. There were several tests when researching about viscosity that I discovered, like styrofoam cup, pouring all these substances down an inclined plane in which timing them. Viscosity has many states of matter. They are all in solid, liquids, and gases. With the viscosity, they are determined by the proteins in the solution, and they vary with the time and the pressure.
Here, we'll show you a video to further discuss viscosity to give you a better understanding.
What is viscosity? Viscosity is the resistance of a fluid to flow. When a fluid is flowing, the molecules comprising it experience friction due to the molecular interaction among them. Stop right there. What does that really mean? It means that different fluids with different viscosities flow at different speed when the same force is applied to them. Another way to look at it is that the force required to induce movement of the fluid will be larger for more viscous fluids. So, why is this important? Viscosity is key for any process involving fluid flow. It will determine, for example, how long will a reservoir take to fill and settle. Viscosity will also determine how much energy is required to pump out process fluid. Viscosity can also help you determine the structure of molecules, such as proteins in a solution, or the force required to inject a new drug formulation into a patient. We hope you found this video interesting. What is viscosity?
I studied many substances when I did these experiments at home, and what I found when working with the substances is when they get on your hands, you can test the viscosity also by rubbing your hands together.
Also, this bar chart and graphs shows the viscosity relations to each other, where honey had the highest, motor oil next, Dawn dish soap, then water, due to their molecular substances. Also, this shows the numbers that we found, where oil, when heated, had a low viscosity and higher when at its regular room temperature. Water at 0.01, gasoline at 0.006, blood at 0.04, and gelatin from 4.1 to 6.8.
Gelatin, which I found, is something called a non-Newtonian fluid, where it is in different states of matter at once. Some liquids are so high that they behave like solids, I found. What I found when working with these fluids is that they're in our everyday life, from filling a pool to pumping energy into a plant, keeping a boat afloat, the flow of faucet in your sink, and something I even found new, the force required to inject into a new drug.
Also, the formula to calculating the shear stress of viscosity would be the force over the applied rate.
This is our project over viscosity. Thank you.